Here is the next example. So the given function f of t equal to t square cos 3t u of t. As I mentioned, u of t is a unit step function, so that means the switch is turned on at t equals 0. So you have the output. That's what the unit step function indicates. Okay. Now, if you look at the property, we can use, look at the properties in the previous video. We can use frequency differentiation property. Okay, pardon me about my writing. Now, if I use the frequency differentiation property, so here the frequency differentiation property is nothing but uh, Laplace transform of t to the power of n f of t equal to minus 1 to the power of n d to, not square. We need to differentiate n times that f of s with respect to s. Now, so this aligns this frequency differentiation property. What I'm going to do, I'm going to convert this cos 3t, find the Laplace transformation of cos 3t. So if you look at the sheet I provided, Laplace transformation table, you can see cos at equal to s over s square plus a square. So cos 3t equal to s over s square plus 9. Now, if I apply this property, frequency differentiation property, t squared cos 3t Laplace transformation is nothing but minus 1 square, okay, minus 1 square d square by ds s over s square plus 9. Okay, so I'm going to do the first differentiation. So to do the differentiation, I have s over s square plus 9. It's look like u by v formula. So u by v formula is u prime v minus v prime u divided by v square. So based on this, so this look like u, this look like v. So s square plus 9 whole square. So u prime s ds by ds is 1 times v s square plus 9 minus v prime is 2s times s. So you will end up with minus s square plus 9 over s square plus 9 whole square. So I kind of expanded it. Now we have to do one more time differentiation. When you do the one more time differentiation, so the denominator, again, it's going to be u by v formula. Okay, so v square in the denominator, so s to the power of 4 plus 18s square plus 81 whole square, and u prime is nothing but minus s square is nothing but minus 2s, and v is same, minus of v prime is nothing but, you will end up with 4s cube plus 36s. Okay, that's v prime, and u is minus s square plus 9. This is f of s. I want you to simplify a little bit better and make it u by make it look like a transfer function in s domain. Okay, the next example, g of t equal to d by dt of t times e to the power of minus t cos t. Okay, now I have a differentiation. Okay, so if you have a differentiation, I believe you can, if you look into the 7 properties I provided. Okay, so where is the, here it is. So time differentiation property, if you have d to the power of n f of t or dt to the power of n, we can use this property. So the given function has a differentiation here, so you can use the time differentiation property. But here, remember, we have 3 terms. Okay, so finding f of s for this and then differentiating later on is going to be, applying that property is going to be a little difficult. So what I did, I differentiated here itself in the first step. So in Laplace transformation, there are most of the examples you can solve it in different ways. Okay, so what I did, I expanded in time domain itself, because expansion of this function in time domain is a little bit easier. So first I derived with respect to e to the power of minus t. So that's minus t e to the power of minus t cos t. Then the second one is with respect to the second term or first term t. Third one is with cos t. Okay, now I have three individual terms. Okay, so I can clearly see e to the power of minus t cos t. I can use the frequency shift property. Okay, and here also I can use either frequency differentiation property or frequency shift property. Okay, now if you look into the table, I have Laplace transformation for t times sine at. Same way, if you have sine, definitely we'll have cos also. T times cos at. I can use that. Or I have here, there you go, e to the power of at sine bt. Laplace transformation at the same time I have Laplace transformation of cos bt. So by using these, any one of these four transformation, first I'm going to do the f of s. So let me go back to the original. Okay, for me, I guess using frequency shift property is a little bit easier. So frequency shift property is Laplace transformation of e to the power of minus t f of t equal to f of s. Actually, let me take this as minus e to the power of minus at. Okay, so here f of s plus a. Okay, so using this is, using frequency shift property is a little bit easier, so that's what I'm going to do. So first I'm going to find this term. So I have e to the power of minus t cos t. For this, even I don't need to use the frequency shift property. If you go back to the table, one of the term you have e to the power of minus at cos bt or something like that. So we can use that transformation. Let me copy. So Laplace transformation of e to the power of minus t cos t equal to s plus 1 over s plus 1 whole square plus 1. Okay, now I'm going to copy t times cos t. I'm going to find the Laplace transform of that, and t times sine t. I'm going to find Laplace transformation of that. Okay, t times sine t, Laplace transformation is nothing but 2s over s square plus a square. A is 1 whole square, and Laplace transformation of cos t times cos t is s square minus 1 square divided by s square plus 1 square whole square. That is t times cos at. Now I'm going to use the frequency shift property. So I already know t times sine t. So e to the power of minus t times t sine t is nothing but, so Laplace transformation of this. All I need to do is substitute, instead of s, I'm going to put s plus 1. Okay, so here a is 1. Okay, so this is the frequency shift property. So based on this property, it must be 2 times s plus 1 over s plus 1 whole square plus 1 whole square. This is the e to the power of minus t times sine t, and same way when it comes to the cos t, e to the power of minus t times cos t. Laplace transformation of this is, here is t times cos t. Now I'm going to replace wherever you see s, I'm going to replace that with s plus 1 whole square minus 1 divided by s plus 1 whole square plus 1 square whole square. Okay, now the transfer function f of s equal to, I have s plus 1 over s plus 1 whole square plus 1 plus 2 times s plus 1 over s plus 1 whole square plus 1 whole square plus s plus 1 whole square over or minus 1 s plus 1 whole square plus 1 square whole square. Now at the end I want you to simplify this. So if I simplify, I have f of s. Okay, the given function is g, so probably I better take this as g of s. Okay, so g of s equal to I have, once I simplify this, s plus 1 over s square plus 2s plus 2 plus, okay, so it's supposed to be plus, but remember when you solve it we end up with minus there and minus there, so we're going to subtract those two. So it's going to be minus s square plus 2s over s square plus 2s plus 2 whole square minus 2s plus 2 over s square plus 2s plus 2 whole square. Further, if we further simplify it, it's going to be s square times s plus 2 divided by s square plus 2s plus 2 whole square. That's the g of s in after transferring into the Laplace domain. So solving these problems is it's look like easier when I'm solving it, but you need to do lots of practice, okay, to solve these examples. I'm going to stop here with the Laplace transformation. In the next video I'm going to work on the inverse Laplace transformation. Thank you.